Hello guys, this is FK from Landcasts, and in this AI dictionary video, we are going to be defining embeddings. Embeddings, that's what we're going to be defining today. So what are embeddings? Now imagine that you went out and you happen to meet an old friend. You meet an old friend and you guys interacted. Then you go back home to your spouse or to your other friends or your roommates, and you're trying to describe the person that you met. Definitely you're going to use some features of the person to describe them. They're this tall, this is their gender, this is their skin color. You might even say, oh, this is how they laugh, this is how they talk and stuff like that. So you're trying to describe an entity that you saw. You're trying to define and describe rather an entity that you saw. This is basically how embeddings work. Yeah, this is how embeddings work, but for computers. For computers, embeddings are ways for computers to recognize items. They are ways for computers to recognize items because computers cannot recognize that somebody is this tall or someone has this skin complexion and stuff like that. That's not how they recognize things like people, chair, a phone, and all others. They have their own special way of understanding these items and be able to say, oh yeah, this is a table, this is a chair, this is a crown, this is a pen, and all that. And that is what embeddings do. So how do embeddings represent data? Now, instead of using the features, features that we described, yeah, embeddings make use of those features, but they don't represent them the way we see them. They represent them with numbers. So embeddings use numbers to represent items. Numbers to represent items. And the numbering system they use helps capture the meaning of an item. Embeddings actually capture the meaning of an item. So each feature is represented by a number and or a range of numbers. And they can describe it along that range of numbers. And by the time they are able to describe something, at the end of the day, things that have the same meaning, that have similar meaning rather, will have similar embeddings. For example, when you're trying to compare a basketball to a football, yeah, they're going to have very similar embeddings. But when you're trying to compare something like an egg to a tennis racket, they're going to have very, very different embeddings. So it kind of shows how closely related some things are to each other and how very different some other things are from each other. And you can use embeddings to represent anything from, let's say, images to files to software. You can use them to represent anything to a computer, like images of people, images of items and stuff like that, different files. You can use embeddings to represent anything. Now, to get a better understanding of how embeddings work, let us play with an example. Let's play with an example. So let's say example. Example. Okay. So let's say in this example, we want to represent a dog and a fish. So we want to represent a dog and a fish with embeddings. Now, the first thing we need to do, we have to come up with features that help us describe these two animals. Features that help us describe these two animals. So I've written down some features. Let me just get them from my notes. First, we have, is it a land animal? So we ask ourselves, is it a land animal? That's a feature. Another feature is it a sea animal? So is it a sea animal? Then another feature we can consider is that can it be used as a pet? Can it be used as a pet? So can it be used as a pet? Can it run? Now, you see how granular these features are. Yeah, that's how granular you need to get with embeddings. In fact, sometimes more granular, because you would be surprised how very, very tiny details differentiate different things. So you have to get this granular. So can it run? Can it run? And finally, can it swim? Can it swim? Let me just make sure I get, yeah, 5 features. So these are features. So we have 5 features that we're going to use to describe these two animals. And for this feature, for each of these features, If the answer is yes, we'll use 1 to represent that particular entity. If the answer is no, we'll use 0, because these are numbers that a computer can recognize. So these features are attached to these numbers. If the answer to any of the question is yes, we put 1. If the answer is no, we put 0. So let's see how we'll describe a fish and a dog. So for dog, we have dog, and we're going to open a matrix. Just open a matrix just to define it. So first, is a dog a land animal? Yes. So we have 1 there, put a comma. Is it a sea animal? No. Can it be used as a pet? Sure, it can be used as a pet. Can it run? Of course, a dog can run. Can it swim? Yeah, let's say most dogs can swim. So, yeah. So, here we have the 5 features that we've used to describe a dog. Is it a land animal? Yes. Is it a sea animal? No. Can it be used as a pet? Yes. Can it run? Yes. Can it swim? Yes. So, these are the embeddings representing a dog. Now, let's look at fish. For a fish, is a fish a land animal? Nope. Is it a sea animal? Yes. Can it be used as a pet? Yeah, of course. Some people use fish as a pet. Can it run? Definitely no. Can it swim? Obviously, it can. And there you have it. Yeah, we have embeddings for a dog and embeddings for a fish. And even though they are different, you can kind of see that in a way they are similar. Now, this is a very simplified example. In larger real-world stuff, you get to have big matrices with different values, different fractions, and stuff. And this can get as big as it can be. But these are embeddings. These are vector points of an embedding, representing each feature and the description of that feature for that particular entity on a certain scale. So this is more like how embeddings look like in the real world, and they are seen as vector representations of a particular data. Now, this way, computers can take, I need to pick up my pen. Computers can take vector representations of 2 or different items and be able to build a relationship between both of them based on how the structure looks like. They can build a relationship between these two. They can know that, oh yeah, a dog is related to a cat, even though they are 2 different things. Both can be used as a pet. Both can run. But, you know, there are still some slight differences, like the kind of whiskers they have, like how tall they can be, how many years they get to live, and so many other things like that. So, embeddings kind of represent data, and that is why computers love them. That's why when you have a prompt, before your prompt gets to the large language model, which is a deep neural network fed with a lot of data, it is converted to embeddings. Because everything within your model training is represented with embeddings. All the data, they are all represented with embeddings. So that's why when this goes in, it finds similar items. That's why a lot of people claim that all these AI models are just fancy autocomplete tools. Yeah, autocomplete. So they are just finding what relates. And at the end of the day, they are able to produce an answer that makes sense to the query that you have fed in. Give you an answer that makes sense to the query that you're fed in, because they are able to define complex relationships between every single item that is contained within them, every single item that is represented within them. So by the time you send in your question, the tokens start getting generated, and all the tokens that are generated, it's making sure that they are all related to each other based on the type of prompt or the prompt that you have sent in. And this way, you get to get an answer that looks very, very close to what a real human being is going to give you. And that's embeddings.